Today I kept this combined session because we have to do the same thing in both the batches. Our class 11th also have started the other time, so maybe we'll have to work out some other time for one of the group. Okay, we'll discuss separately, don't worry. This is the case. Question number 1, this is DPP number 5. Question number 1. The total charge Q is distributed in this volume. Outer radius is R0, inner radius is R1. This is a non-conducting spherical shell, non-conducting solid sphere having a cavity. The outer radius is R0, inner radius is R1. Total charge is Q, and we need to calculate the. Can we apply the Gauss law? Can we apply the Gauss law here? बाहर वाली radius है R1, अंदर वाली radius R0, अंदर वाली radius है R1. Yes, can we apply the Gauss law here? Is there a symmetry? Yes, because जितनी भी shells होंगी, they all will be spherical, hollow spherical shells. We can combine them, so there will be a symmetry applicable. And in this case, the charge is also uniformly distributed. Volume charge density rho, which is total charge divided by total volume. Total charge is Q and total volume is 4 pi by 3 R0 cube minus R1 cube. This is the total charge density, that is total charge density, volume charges. Now in these three different regions, we have to calculate the electric field less than R1, between R1 and R0, and greater than R0. So if at any point inside we have to calculate, first is region R less than R1. It will be a spherically symmetrical. हम वहां से पास होने वाला So consider a Gaussian surface, a spherical Gaussian surface passing to that point, and apply E dot dA. So integration of E dot dA is charge enclosed upon epsilon naught. Inside there is no charge, so in this particular region the electric field will be zero. At any point inside that cavity R less than R1, the total electric field will be zero. Second is, suppose we consider a point which is in between this. Second reason, when R is greater than R1 but less than R0. So at any point here we will consider a Gaussian surface, a spherical Gaussian surface. It encloses some amount of charge. Not all of it, but it will be having some amount of charge enclosed by it. इसके अंदर का जो charge है, this charge we have to calculate by using again the volume charge density. Consider a Gaussian surface passing to that point, that of radius small r. Apply again Gauss theorem, integration of E dot dA is equal to total charge enclosed by epsilon naught. इधर आ जाएगा E into 4 pi r square. Now r is this. R is the radius of that point, distance of that point. Density is rho and volume अभी आ जाएगा इसका 4 pi by 3 r cube minus r1 divided by epsilon naught. Understood? हमें ये वॉल्यूम के अंदर का चार्ज चाहिए, the shaded portion, because inside there is a cavity, there is no charge. So in this shaded portion, outside volume 4 pi r cube और ये अंदर वाला जो hollow portion है that is 4 pi by 3 r cube minus r1 cube. So E into 4 pi r square. Rho is q by 4 pi by 3 r naught cube minus r1 cube और ऊपर आएगा ये 4 pi by 3 r cube minus r1 cube divided by epsilon naught. कोई स्टेप समझ में ना आया या क्लियर ना हो तो प्लीज पूछ लेना. हमने इस रीजन में इलेक्ट्रिक फील्ड का फॉर्मूला कैलकुलेट करना था. देयर आर थ्री डिफरेंट रीजन. Inside a non-conducting solid sphere of radius r0 there is a cavity of radius r1. सबसे अंदर वाले रीजन में रीजन 1 there is no charge enclosed, electric field will be zero. In between the two shell we consider a Gaussian surface passing through that point of radius r. Yeah, integration of E dot A is total charge enclosed. Total charge के लिए charge density multiply by volume. ये 4 pi by 3 4 pi by 3 gone. E into 4 pi r square is q times E into 4 pi r square is q times r cube minus r1 cube divided by r naught cube minus r1 cube into epsilon naught. राइट. अब ये 4 pi r square से राइट साइड में डिवाइड कर देंगे. इलेक्ट्रिक फील्ड इन बिटवीन देम इज q डिवाइडेड बाय 4 pi epsilon naught r square r cube minus r1 cube divided by r naught cube minus r1 cube. This is the electric field in this region where there is charge. Electric field in the region between these two shell r0 to r1. This Gaussian surface was passing through point P which lies in between them. Right, so this case we have to consider the charge which is enclosed by this much inside the Gaussian surface. So हमने total charge निकाल लिया by the volume multiplied by charge density. This is the electric field. This is the electric field inside in between this region 2. Reason number 3 जो सबसे बाहर वाला reason है, when r is greater than r0. For that reason, again the charge enclosed. So now we need to calculate the electric field at any point outside this outer sphere. वहां से पास होने वाला Gaussian surface, will consider the Gaussian surface. जैसे हमने solid sphere के लिए formula किया था, exactly similar method, but यहाँ पर अंदर cavity है, so that much charge will be subtracted. This charge is Q. अभी हमें calculate करना है to a point which lies outside. So a Gaussian surface passing through that point will enclose the whole charge. So integration of E dot dA is equal to total charge enclosed upon epsilon naught. Since it encloses the whole sphere, so इसका सारा का सारा charge Q will be completely inside. E will be 1 by 4 pi epsilon naught Q by r square. Electric field in the outermost region is again similar to that of point charge kept at the center. Again, this question is asked in the exam. Right? Gaussian surface हम यहाँ पे use कर सकते हैं. We can apply the Gauss law because it is still a symmetrical electric field. By using the charge density into volume, we can calculate the total charge. So inside the innermost region, it is 0. In between them, we'll calculate the charge enclosed by that smaller sphere. And outside the outer one, total charge will be again similar, total field will be again similar to that of point charge kept at center. Clear? Yes. Question number 1 understood? बेटा ये गॉस लॉ के एप्लीकेशन में जो हमने सॉलिड स्फीयर का किया था केस, उसी का एक नेक्स्ट स्टेप है, नेक्स्ट लेवल. Instead of the whole solid sphere, there is a cavity inside. Right. Second question. Yes, second question. A sphere of radius r naught carries a volume charge density rho. A spherical cavity of radius r naught is removed out. What is the direction of magnitude? What is the direction and magnitude of electric field at point A and at point B? Sorry. First वाले केस में अभी थोड़ा एक second part रह गया. In the first question, the second part, if we consider a charge q at the center of cavity, what changes occur in second and third? What changes will occur in second and third?
सर
अगर
ये
अब
वो
हम इस
लिखा है सर
cavity
1 2 and 3 लिखा है
बेटा
सर 1 2 and 3 लिखा है आपने 1 मिस कर दिया था
अच्छा 1 2 and 3 राइट मतलब in the all three reasons. So अगर अब हमने cavity के center पर एक charge रख दिया q, then what will be the new electric field in all the three reasons? So this is the outer and inner one, and there is extra charge q is placed here. Small q center पर है and capital Q is uniformly distributed. This is the question number first. Second part. When we put a charge at the center of the cavity, what changes will be there in the electric field? So reason number 1, which is the inside this cavity, जहां पर हमने पहले Gaussian surface बनाई थी, so total charge enclosed was 0. Now that charge will not be 0. ठीक है, समझ लो भावना. अभी अंदर सबसे अंदर रीजन में था रीजन 1, if you consider a Gaussian surface passing through that point, inside here it is in reason 1, when r is less than r1, we apply integration of E dot dA is equal to q by epsilon naught. E into 4 pi r square is q by epsilon naught. So electric field in the innermost region is q by 4 pi epsilon naught into r square. Reason 2, if we consider reason number 2, in reason 2, now again there will be two charges. One is at the center, that has to be also included, plus the one which is inside this Gaussian surface. In reason number 2, which is between R0 and R1, E dot dA is equal to total charge enclosed. Total charge enclosed में center का Q plus rho into 4 pi by 3 R cube minus R1 cube. This will also come divided by epsilon naught. So accordingly that formula will change. E into 4 pi R square is 1 by epsilon naught Q plus ये आ जाएगा capital Q times R naught cube minus R1. E is equal to 1 by 4 pi epsilon naught R square. Sorry, this is small q. स्मॉल क्यू प्लस कैपिटल क्यू इंटू आर क्यू माइनस, सो बस हमें अंदर वाले चार्ज में चार्ज इनक्लोज में क्यू और ऐड कर देना है, द चार्ज विच इज also present at the center of this cavity. So now we have to include this whole charge inside this cavity, inside this Gaussian surface. So E accordingly आ जाएगा, E is equal to 1 upon 4 pi epsilon naught r square, 1 upon 4 pi epsilon naught r square. It will be Q plus capital Q times R cube minus R1 cube divided by R naught cube minus R1 cube. This is the electric field region in between the two charges. Okay, and the third one is outside the both outside this sphere. बाहर वाले के लिए फिर से the total charge will be Q at the center, that also have to be included, plus capital Q in this gap. So if this point P where it is outside के लिए again integration of E will be integration of E dot dA will be total charge enclosed. Total charge enclosed will become Q plus capital Q. So this Q has to be included in the charge enclosed by this by the Gaussian surface. So Q plus capital Q divided by 1 by 4 pi epsilon naught r square. So अगर हमने cavity के center पर एक charge रख दिया Q, then the electric field formula will change according to this. Clear? Okay. अब आते हैं question number second. Question number second, we did something like cavity also. A sphere of radius r naught carries a volume charge density rho, and the spherical cavity of radius r naught by 2 is removed out. What is the magnitude and direction of field at point A? A is the center of the cavity. A is the center of cavity, and B is at the one end. So cavity वाले cases जो हमने किए थे, if you remember, cavity in a solid non-conducting uniform sphere. Yes. In this there is a cavity, और इस cavity के अंदर का जो electric field calculate करने के लिए we derived this method. हम पहले पूरे पे positive charge लेते हैं, and then the removed portion we consider a negative charge. Considering the whole sphere to be positively charged, then the removed sphere to be negatively charged, and then when we superimpose that positive and negative charge, that positive and negative charge they cancel out each other. तो इस कैविटी के अंदर किसी भी पॉइंट पर जो इलेक्ट्रिक फील्ड हम कैलकुलेट करते हैं बाय द सुपरपोजिशन ऑफ पॉजिटिव एंड नेगेटिव चार्ज, बाय द सुपरपोजिशन ऑफ पॉजिटिव एंड नेगेटिव चार्ज. सो अभी इसका फॉर्मूला क्या था, इफ एनीबॉडी रिमेंबर, द फॉर्मूला वाज इलेक्ट्रिक फील्ड इनसाइड द कैविटी ऑफ अ नॉन कंडक्टिंग solid. Electric field inside the cavity of non-uniform, it was E is equal to rho into L by 3 epsilon naught. where L was the vector joining center of cavity to the center of sphere. So in this case, that vector will be L. किसी भी नॉन कंडक्टिंग सॉलिड स्फीयर के अंदर अगर कैविटी हो, इन दैट कैविटी इलेक्ट्रिक फील्ड वाज यूनिफॉर्म. Electric field was uniform, and that uniform electric field is given as rho into L by 3 epsilon naught. In this case, ये total electric field is total radius is R naught, and this radius is R naught by 2. So L की वैल्यू आ जाएगी rho into R naught by 2. Electric field will become rho into R naught by 2 divided by 3 epsilon naught, which becomes rho R naught by 6. Understood this? इलेक्ट्रिक फील्ड हमने कैलकुलेट किया था किसी भी इनसाइड द कैविटी ऑफ अ नॉन कंडक्टिंग सॉलिड स्फीयर. पहले पूरे में पॉजिटिव अज्यूम कर लेते हैं, फिर कैविटी वाले पोर्शन में नेगेटिव, एंड द इलेक्ट्रिक फील्ड इनसाइड द कैविटी कम्स आउट rho r by 3 epsilon naught. Rho L by 3 epsilon naught. L here is the line joining center of the sphere to center of cavity. So rho r naught by 6 epsilon naught. बेटा ये समझ आ रहा है?
Yes, sir.
Yes, sir.
What will be the direction of electric field? Towards right. Electric field थी उस L vector की तरफ, so electric field will be along that vector at every point. In fact, electric field is towards right. At point A, electric field will be towards right or plus I cap. जब हम इसके अंदर point A पे निकाला था, then we use that formula rho into R rho into L by 3 epsilon naught. Second case is we have to calculate the electric field at point B. B is at the surface of this solid sphere. इस क्वेश्चन के लिए आपको नोट्स के जो फॉर्मूलेज थे वो याद होने जरूरी हैं. इफ यू डोंट remember those formulas, you can open your notebook straight away, see in the notes, verify, check yourself. You should not take any formula lightly. If you are not able to recall the formulas that you derived, जैसे ये formula हमने cavity के लिए किया हुआ था, if you don't remember this formula, you can open your notebook and you can verify that it is there. करते करते क्वेश्चन वो आपको फॉर्मुलेज याद हो जाएंगे, बट अभी जब आप क्वेश्चंस कर रहे हो साथ में, these questions are little tricky, and yes, they involve the formula application and they involve the concept application. So just देखने से समझ नहीं आएंगे. You will have to check and you'll have to convince yourself why we are using this formula in this particular question. अब जैसे इसका जो A part था, यानी जब हमने सेंटर पे निकालना था, that was the formula that we did. Second case जो है, when we have to calculate the electric field, at point B, and point B is one edge. It is now not inside the cavity. We have to find the electric field for this uniformly charged non-conducting solid sphere with a cavity inside. We have to find the electric field at point B, which is on the surface of this solid sphere. So उसके लिए we don't have any formula, but we can still use the principle of superposition. Principle of superposition says any case having cavity, any solid sphere having cavity, we can create by assuming first the whole charge to be positive. अभी हमें calculate करना है at point B. B is this point, and where the charge density is rho. So what we do first, we consider this as a whole solid sphere, positively charged whole big solid sphere, then the negatively charged, sphere inside the cavity. So if we assume that the whole charge at this in this bigger solid sphere is Q1, and we calculate electric field due to that at point B, and then electric field inside this cavity, the negative charge. कैविटी वाले क्वेश्चन सॉल्व करने के लिए पहले हम पूरे में पॉजिटिव चार्ज अज्यूम कर लेते हैं, फिर जितना पोर्शन रिमूव किया वहां पे नेगेटिव चार्ज, और दोनों का सुपरपोजिशन करके we can calculate the total charge. So assume that this total charge is Q1. Q1 is rho into 4 pi by 3 R cube. R naught Q, because R naught is the radius. इसकी इलेक्ट्रिक फील्ड निकालेंगे हम पॉइंट B पे, and then we have to consider the same density negative charge in this cavity. So this cavity में जो charge है, that is minus Q2, which will be minus rho into 4 pi by 3 R naught by 2 whole cube. Q1 is the charge on the solid sphere. Q1 is total charge on the bigger sphere. बड़े वाले पे जो charge आएगा, that is charge density into its volume, and volume is 4 pi by 3 to minus Q2 is total charge in the cavity. दोनों की charge density same है, total charge in the cavity. And so that becomes magnitude wise rho into 4 pi by 3 R naught by 2 whole cube, which will become rho into 4 pi R naught cube divided by 24. So हम पहले पूरे वाले स्फीयर की वजह से यहाँ पे कैलकुलेट कर लेते हैं at point B, which is E1 suppose. तो पूरे स्फीयर के सेंटर से डिस्टेंस हो गई R1 R0, और फिर हम छोटे वाले कैविटी से निकाल लेते हैं, छोटे वाले कैविटी के सेंटर से डिस्टेंस होगी इस पॉइंट की R0 प्लस R0 by 2, which is 3 R0 by 2. So electric field due to the full solid sphere, बड़े वाले की वजह से E1 और छोटे वाले की वजह से जितने पार्ट हमने रिमूव किया कैविटी का, that is, so it will be K Q1 by R0 square minus K Q2 by 3 R0 by 2 square, by using the simple formula of the electric field due to a charge. KQ by R square. So बड़े वाले स्फीयर में चार्ज है Q1, उसके सेंटर से डिस्टेंस है R0. छोटे वाले स्फीयर में चार्ज है Q2 और उसके सेंटर से डिस्टेंस आ गई 3 R0 by 2. ये समझ आ रहा है ना कैसे 3 R0 by 2 है? Because R0 is the total radius, इसकी diameter थी R0, so ये हो गया R0 by 2. Now substitute the value of Q1 and Q2. K is 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught. Q1 is rho into 4 pi by 3 R naught cube divided by R naught square. ये आ गया first term, minus second term is 1 upon 4 pi epsilon naught. Q2 is rho into 4 pi R naught cube divided by 24 into R naught square. 4 pi gone, 4 pi gone. पहले टर्म में कितना आएगा? रो R by 3 epsilon naught, rho R naught by 3 epsilon naught from the first term minus सॉरी क्या नोट हुआ यहाँ पे 4 pi by 3 r naught. This is 3 r naught by 2 whole square. 24 तो चार्ज था, समझ नहीं आ रहा, शायद किसी ने गलती पॉइंट आउट नहीं की। रो 4 pi by pi r naught क्यूब डिवाइडेड बाई 24 और इसका स्क्वायर करोगे तो ये आ जाएगा 9/4 टाइम्स r naught स्क्वायर। दिस वाज 3 r naught by 2, उसका स्क्वायर करेंगे तो 9/4।
24 क्या है एक बार बताना।
24 बटा ये है ना 8 इंटू 3 24,
अच्छा अच्छा
और ये 3 r naught by 2 का स्क्वायर करेंगे तो 9/4 आ गया, ये नीचे आ गया 54 माइनस रो r naught by 54 epsilon naught। E1 is electric field due to the full solid sphere. E2 is electric field due to that small sphere which is inside the cavity but negatively charged. पूरे का पॉजिटिव चार्ज, कैविटी का नेगेटिव चार्ज दोनों सुपर इम्पोज करेंगे, then the cavity will be neutralized and it will create the actual field. Rho r naught by 3 इसको सॉल्व करोगे तो ये 18 minus 1 17/54 rho r naught by epsilon naught, that is the answer. Electric field at point B, field at point B because of this reason पूरे स्फीयर में, पूरे में सॉलिड स्फीयर पहले अज्यूम किया पॉजिटिव चार्ज, फिर जितने पार्ट में कैविटी थी उसको हटा के वहां पर नेगेटिव चार्ज अज्यूम किया एंड देन वी कैलकुलेटेड द इलेक्ट्रिक फील्ड ड्यू टू दैट रीजन at point B. This comes out 17/54 rho r naught by epsilon naught. Right. So these questions are concept oriented questions like application method हमें कैसे यूज करना है। कैविटी वाले क्वेश्चंस में कैविटी के अंदर निकालने के लिए, कैविटी वाले क्वेश्चन में कैविटी के बाहर निकालने के लिए द मेथड इज सेम। पूरे में पहले पॉजिटिव चार्ज ज्यूम करेंगे, फिर कैविटी में नेगेटिव चार्ज ज्यूम करेंगे, दोनों के अलग अलग इलेक्ट्रिक फील्ड निकालेंगे और फिर दोनों का सुपर इम्पोजिशन कर देंगे। वेरी नाइस। आई विल शेयर दिस पीडीएफ आल्सो, सो अगर आप नोट नहीं कर पाए हो या फिर you want to see it again, you can see after the class. I'll share this PDF in the group. Question number 1 and 2, because we have to discuss many questions, so speed should be a little faster. Question number 3, a cube of side length L has one corner at the origin of coordinate and extends along the positive x, y and z axis. If electric field in the region is AY plus B times J cap, determine the charge inside the cube. Okay. Electric field is towards J cap and this is a cube of side length L. Right. Assume it to be a cube of side length L. So this is X, Y, and Z axis. Electric field in this region is given as AY plus B times J cap. Electric field is given as AY plus BJ cap and we have to find the charge. Electric field is like this, always along the cap. So it is entering through one phase and going out from the other phase. We have to calculate total flux passing through this cube and that will be equal to Q by epsilon naught. So जहां से ये बाहर निकल रही है और जहां पे अंदर जा रही है, where it is going inside at this surface xz, y will be 0, E1 will become B. And here it will be y is equal to L. So electric field E2 will become AL plus B. Total flux coming out of this Gaussian surface is net outward flux minus flux that is going inside. Phi close this, phi 2 minus phi 1, which is E2 into A minus E1 into A. E2 is AL plus B times L square, E1 is B times L square, and this is equal to total charge enclosed by epsilon naught. So it becomes how much? Total charge enclosed is AL cube into epsilon naught. राइट सर क्वेश्चन किए थे हमने इसमें इलेक्ट्रिक फील्ड वाई डायरेक्शन में हमने जो क्लास में एग्जांपल किया था उसमें इलेक्ट्रिक फील्ड वाज इन एक्स डायरेक्शन फाइन electric flux passing through any closed Gaussian surfaces q enclosed by epsilon naught. So q enclosed will come out by using the flux. Question number 4. A spherical charged rubber balloon carries a total charge q on its surface. At time t is equal to 0, the non-conducting balloon has radius r0. After that, balloon is inflated such that radius increases to 2r0 in time t second. Okay. Determine the electric field outside as a function of time just outside the balloon and add r is equal to 3.3 r0. Okay. So in this case, charge remains same, only radius is increasing. Question number 4. Spherical charged rubber balloon, its radius is increasing. Right. So here the total charges initially q radius is r0 and then radius changes to r0 on the balloon. That balloon is inflated. हमें एज ए फंक्शन ऑफ टाइम बताना है इसका मतलब चार्ज तो सेम ही रहेगा क्या चेंज हो रहा है इट्स रेडियस इज चेंजिंग q it is r0 finally the radius is 2 r0 in a time of capital T second assuming that the inflation of this balloon or increase of radius is uniform. So charge is increasing the with a constant rate, sorry, radius is increasing, the rate of change of radius because जब surface पे निकाल रहे हैं तो total charge same है. At any time the electric field will be kq by r square. Just we need to calculate r as a function of time. Rate of change of radius is 2 r naught minus r naught and divided by time capital T. This question you can see in your own PDF. It says that its initial radius is r naught and the balloon is inflated such that radius increases to 2 r naught in a time capital T second. R naught से 2 r naught in a time of capital T second. So assuming it to be a linear increase, rate of change is r naught by t. So we can calculate radius as a function of time t. T is equal to 0 पे r naught, t is equal to capital T पे 2 r naught, and here it is r naught plus r naught by capital T into small t. then electric field on its surface. Electric field on the surface of any solid or hollow sphere is just kq by r square, or we need to substitute this as r naught into 1 plus small t by capital T whole square. Second tha, at a distance of 3.3 r naught, 3.3 r naught point is outside only, and as long as the point lies outside, it doesn't matter. It doesn't matter that how is the what is the size of that sphere. If it is symmetrical, we can assume the total charge to be present at the center. So जब हम 3.3 r naught की बात कर रहे हैं, which means it is way beyond this boundary, and the total electric field will be just given as kq by r square. In both the cases where it was r naught, 3.3 r naught, and when this radius is 2 r naught, then also 3.3 r naught is. In both the cases, this is outside only. So electric field will be kq by r square, q naught by r square, and r is 3.3 r naught whole square. Right. So these are some concept application based questions. आपको उनसे knowledge भी derive करनी है. It's not just the answer to this question is important. It's also important that you have to understand the concept behind it. Question number 5. A charge, this is one option correct objective. A charged metallic ball is lowered into an insulated metal can. Thread insulated है, stand insulated है. This is a metal can और उसके अंदर एक metallic ball है that is charged. The ball is made to touch the bottom of can, then it is placed on the disc of electroscope as shown below. Okay. The final observation must be. Final observation must be. Okay. Again, question क्या बोल रहा है? A charged metallic ball is lowered into an insulated metal can. ठीक है. Now it is lowered and the ball is made to touch the bottom of the can. Okay. So now it is kept on this gold leaf electroscope, which is as shown here in the diagram. So जो metal can था, that metal can, what happens when we touch it? जब हम sphere को यहाँ touch कर देंगे, since the charge will always lie on the outside, charge always lies. So when this is insulating thread, the whole charge of this metal will come on the outer surface of this can. The charge of this ball goes to the outer surface because inside any metal charge cannot exist. This ball, which was initially charged, when it touches the bottom surface, the charge comes on the outer surface of the can. अब इस ball को निकाल के हमने इस disk पे रख दिया. Now since this ball is uncharged, after touching the base, it become uncharged, and now it is connected to a gold leaf which is already having some charge. So अगर ये uncharged है, then by the conduction, some charge will come on its surface. नीचे जो electroscope है उसका charge कम हो जाएगा. Some amount of charge from the electroscope will decrease, and as a reason, electroscope will converge, not diverge. the leaves of electroscope will converge, it will not diverge. So it's basically a simple question, only the language is tricky. पहले एक metal surface metallic can के अंदर this was hanging from insulating thread. When it touches the bottom, the charge of the ball, metallic ball, goes to the metal can. क्योंकि अंदर की तरफ charge नहीं हो सकता, the whole charge of this metallic ball goes on the outer surface, and this ball become neutralized. So this neutral charge, now this neutral ball is kept on the surface of a metallic disc, which is connected to a electroscope. Electroscope का charge थोड़ा सा metal में आ जाएगा, that will share by conduction, and therefore the charge on this gold leaf will reduce as a result. As a result, it start collapsing, it start converging.
So could you explain this again?
Okay, the question is this is the question I'm talking about. There is a metallic can with a small hole, and a ball is lowered through the insulating thread. When this ball touches the metal can bottom surface, when it touches the bottom surface, what happens is that the total charge of this metal will be given to this can. And since metal cannot have charge on the inner surface, in any metal, the whole charge will go on the outer surface. So this metallic ball charge goes on the outer surface of the can. This is the first step. Now ball is removed from here. The ball become neutralized when it touches the bottom surface, when it touches the surface of the metal. And now this ball is taken from here and it is kept on a disc of an electroscope as shown. Yes. The ball is made to touch bottom of the can, then it is placed on the disc of electroscope as shown. This electroscope disc is connected to a positively charged gold leaf. And since now this metal is uncharged, this uncharged metallic ball will take the charge from leaf, and that reduces the charge on the gold leaf, reduces the angle between them. So charge कम हो गया, इसलिए repulsion force कम हो जाएगा, and the gold leaf starts collapsing. Clear?
Yes, it's clear. Thank you.
Question number 6. Two thin spherical shells of radii R1 and R2 contain uniform charge densities of sigma 1 and sigma 2 respectively. Under which of the given condition E is equal to 0 for R less than R1 greater than R2? Okay. Two thin spherical shells of radii R1 and R2 contain uniform charge densities sigma 1 and sigma 2 under which of the following conditions? So these are actually concentric shells having the charge density sigma 1 and sigma 2. Radius is R1 and R2. Question number 6. Question number 5 I explained in the paper itself. Yeah, there are two such concentric shells having charge density sigma 1 and sigma 2, and radius is R1 and R2. So that means there is some charge on the inner surface, which is Q1, and some charge on the outer surface, that is Q2. Q1 is sigma into 4 pi R1 square, and Q2 is sigma into 4 pi R2 square. Now it says that under which condition the electric field in between R1 and R2 is 0. So when we consider a point here lying between R1 and R2, then the net electric field is 0. The net electric field inside the net electric field will be 0 if the total charge enclosed becomes 0, or total charge enclosed 0 तब होगा जब जितना चार्ज इस पर है, अगर हम उतना ही नेगेटिव चार्ज सेंटर पे रख दें. If you place exactly same amount of charge at the center, so if minus q1 means minus sigma into 4 pi r1 square is placed at center. इस गॉसियन सरफेस के अंदर टोटल चार्ज माइनस q1 सेंटर का और q1 स्फेरिकल शेल का, टोटल चार्ज will become 0. Then electric field will become 0 in this region, r less than r2 greater than r1. तो ये वही कॉन्सेप्ट क्वेश्चंस हैं जो हमने क्लास में किए हैं, बट थोड़ी लैंग्वेज ट्रिकी है और अपोजिट सोचना है हमें. पहले सेंटर पे चार्ज था, हमने स्फेरिकल शेल्स में इनसाइड आउटसाइड वी कैलकुलेटेड द चार्ज एंड देन वी फाउंड द इलेक्ट्रिक फील्ड. अभी इसमें सेंटर पे माइनस q1 अगर रख देंगे, then in this Gaussian surface the total charge enclosed becomes 0. Minus q1 at the center, q1 on the first surface, total becomes 0, and that makes the total flux to be 0, electric field to be 0. So answer to question number 6 is, yeah, answer to question number 6 is C. A charge of minus 4 pi sigma 1 r1 square is placed at the center of the shells. Yeah, next question number 7. Yes, question number 7. A point charge q is placed above a spherical surface as shown, then E at surface is 0, BE is okay. Point charge q is placed above a spherical surface as shown. और surface के अंदर कोई charge नहीं है, surface पे कोई charge नहीं है. Electric field at surface is 0. No, not necessarily. Why it will be 0? It will be kq by r square. At every point there will be some charge.
So will it be option C?
Option
C.
C. Yes, option C. Very nice. How did you figure out so fast?
Because I solved it an hour ago.
You solved it?
An hour ago.
Okay, yes, very nice. So basically, when it is the closest point, that is the maximum electric field, and when it is the farthest point, then it will be the minimum. Point A, it has maximum. Point B, it has minimum. So at point A, it is kq by r naught by 2 whole square, and at point B, it is r naught by 2 plus 2 r naught, which is 5 r naught by 2. So the maximum electric field will be kq by r naught by 2 square. E max is when the distance is smallest, kq by r naught by 2 square. And the minimum electric field is k into q divided by 5 r naught by 2 whole square. So that becomes C option. It should lie between these two values, because all the other distances will be greater than r naught by 2 but less than 5 r naught by 2. Okay. Question number 8. Two concentric conducting thin spherical shells A and B having radius RA and RB and charges Q and QB, variations of electric field of the line through the center of the shell. Okay. So again, it is a similar type question, but it has to be represented in the graphical form. Concentric shell where RB is greater than RA. कंसेंट्रिक शेल के अलग अलग रीजन में हम इलेक्ट्रिक फील्ड कैसे कैलकुलेट करते थे, with the help of charge redistribution. So RA is for the inner one, radius of A, RB, charges are QA and QB. QB is negative, that information is missing here. That information is missing here, that QB is negative, but the magnitude of QB is greater than Q1. So you can write here QB is a negative charge. If it is negative, then accordingly we will decide QA positive, QB negative, overall is negative. So in a concentric shell, अंदर कोई charge नहीं है, so ये zero आ जाएगा, बाहर QA. QA will induce minus QA, outside पे plus QA. Outside become total charge as QA minus QA minus QB. And since QB is greater than QA, that means this charge is negative. So this charge is negative charge. So इसमें हमने जो इलेक्ट्रिक फील्ड के फॉर्मूले कैलकुलेट किए थे, सबसे अंदर रीजन में there will not be any electric field because there is no charge. In between it will be K into QA by R square, or outside region में it is K times QB minus QA, but direction will be opposite. Like inside it is from positive to negative. The outside one charge is negative. Because that charge is negative, electric field is coming inside. So that will be vectorally written as negative. Direction wise, it is opposite to the second electric field. Electric field is K times QB minus QA divided by R square. And this direction is opposite, so that will be a negative electric field. E versus R graph. Up to RA, it is 0. Electric field inside the inner shell is 0. RA to RB, it is inversely proportional, and then it is negative and inversely proportional to R square. Right. Which option is this? First option. First option. So this information was missing here. You can add this in the question. That the charge of B is negative, A is positive, and the magnitude of charge on B is greater than charge on A. Clear? So we did these type of questions, but we didn't draw the graph. This question is in the form of graph. So you have to just draw the graph. And changing, that means electric these type of question have been asked in exams. We have covered these type of questions in the class examples also. Right. Next question, question number 9. Question number 9, that is related to the parallel plate theory concept that we did. Two charged plates with plate charges Q and 3Q are placed as shown. Another plate with charge Q is placed between the two plates. Final charge Q3 and Q5 on the surface of plate. Right. So basically 3Q, Q and Q. These are the charges on the three metallic plates. And we use the concept of parallel metallic plates to determine the total charge on each surface. तो हमने कुछ किया था ऐसे किसी भी combination में half of the total charges on question number 9. First plate has a charge 3Q. There is a plate in between which has a charge Q. and the lower plate also has a charge Q. These charges are redistributed in the plate. Total become 5Q, 5Q half, 5Q by 2, 5Q by 2 on the outermost surface. Out of 3Q, 5Q by 2 come on the upper surface. Then by using the charge conservation, Q by 2 should be here. On the facing surfaces, always charges have to be equal and opposite, because metal के अंदर से कोई भी Gaussian surface pass होगी, then it should not contain any charge. If one side is Q by 2, on the other side it becomes minus Q by 2. And now the second plate has total charge Q. By using the charge conservation, on the other side it should have charge plus 3Q by 2, and this will induce minus 3K by 2 on the facing surface. Outermost surfaces of the whole combination always has half of the total charge, and this we did in the class. You just have to apply this parallel plate theory concept to find the charge on each surfaces. हमें इसमें बताने थे कौन कौन से Q3 and Q5, Q1, Q2, Q3, Q4, Q5, Q6. So we got the value of all these Q1, Q2, Q3, Q4, Q5, and Q6. By using that parallel plate theory concept, we did two such examples. One was concentric metallic shell, another was the parallel plate theory and parallel plate concept. So answer to question number 9 is which option? Q3 and Q5. A. Q3 and Q5. Yes, it's A option.
Yes, sir.
Number 9th, A. For uniformly charged conducting solid sphere cylinder of infinite length, which of these graphs shows the variation of E versus R? Okay, question number 10th. So ये थोड़ा thick solid cylinder है. Thick solid cylinder means inside the cylinder electric field will be 0. Outside the cylinder it will become K lambda by R. This is the thick cylinder having a charge. So conductor के surface पे charge होता है, inside there is no charge. जैसे sphere के case में जब outside पे charge होता था uniformly distributed, then we can assume the whole charge is present on the center as a point. Similarly here, when it is a cylinder, the whole charge can be assumed on the wire or on the thread kept at the axis. Infinite line wire के लिए electric field outside was 2K lambda by R, or it can be written as lambda by 2 pi epsilon naught R, and the electric field inside will be 0 because there is no charge. There is no charge, so inside it is 0 and outside it is inversely proportional to R, 2K lambda by R. So the answer is under 0 by inversely proportional to R. Answer is B. Right. Question number 11. A solid non-conducting sphere of radius r has a uniform distribution of charge throughout the volume. At a distance x from the center, the electric field is directly proportional to. So this was the standard formula. Electric field inside a solid sphere is rho r by 3 epsilon naught. R को हम x लिख लेते हैं, यहाँ पे it is given as x. Or the same was k q by capital R cube times small r. So electric field is directly proportional to x. Right, that was the formula we have already derived for a solid non-conducting sphere having uniform distribution of charge. Question number 12. Consider a spherical symmetric charge distribution with charge density varying as rho is equal to rho naught 1 minus small r by capital R. Electric field at R less than R. So less than R के लिए हमें now we have to again apply the Gauss theorem. To apply the Gauss theorem, we need to calculate the total charge enclosed by it. अब में से किसी ने क्वेश्चन किया था होमवर्क में? Now you tried this question also?
I didn't get it, sir.
You didn't get it. Okay, but you tried.
Yes, sir. I didn't get most of the questions, but I tried.
You didn't get most of the questions that you tried. Okay. Fine. So that's why these are taken as a class practice example. I have shared that one extra as exercise bank, question bank. Those are easy that you can try. You'll be able to solve more than 80-90% of the questions. Okay. So question number 12, inside a solid sphere, the density is not uniform anymore. The density is a function of R. Earlier we used that charge is distributed uniformly, so we can directly write the total charges, charge density multiplied by volume. But here in this question, the charge density is a function of small r. With the distance from the center, the radius, the density is changing. It is rho is equal to rho naught 1 minus small r by capital R. So revision classes we start हो गई हैं and those will be on Tuesdays and Thursdays as of now. For the chapter number 1, for so like I will be now emphasizing more towards the numerical questions in the class. I'll start from the basic. I'll also give the theory and all those things, those stuff. And I also shared you one PDF of handwritten notes for chapter number 1. So there will be a subjective test maybe in the coming weekend because still we are discussing few topics of the chapter number 1, which will also have the questions of the similar sort. Similar sort means like some derivation, some numerical, and some conceptual question. Fine. So look, thoda sa bhi online mode mein bhi you have to adopt and you have to adopt fast. Booklet jab aap collect kar pana tab kar pana, it's not a problem, but I have shared the question bank which is like 180 190 questions from these first 2 chapters. So you have to now start practicing those questions, and I will also be verifying, I'll also be cross checking. Apart from our usual 3 days class, one extra day that we can have for the extra discussion of the your questions that you are trying but you are not able to get answer. Every Sunday night 8 p.m. or something I will share, and that will be a common doubt session for all the groups, right? I mean, now you also have to put the effort. You'll also have to put in the number of hours. Whatever we are doing in the class is not sufficient. Is not sufficient for you to crack exam. It's okay to gain knowledge, but if you want to crack, if you want to earn a rank, then you have to give your effort also. You have to work hard from your side also. मतलब ऐसे one by one, all these questions are not supposed to be done in the class, but I am doing because I want you to first get to know how what are the variety of questions and how we can approach these questions. And with time, when you will become better and a little more perfect, I will not be doing this exercise in the class as we are doing question by question now. But yes, these are the 2 resources that we will be following. One is the topic wise DPPs like we are doing here on the Fridays class, and another the answer the question bank that I have shared for the chapter number 1 or unit number 1. These 2 are must solve for everyone. DPPs mostly it will be solved in the class. Other exercise bank you have to solve in the homework, and once you submit me your answer key, only then I will provide you those answers to those questions. The booklet, that academy booklet, also doesn't have the answers back. At the back, there is no answer for those questions back. Right? So there was a psychological reason behind that, because in exam also you don't have any answer key available. So you have to first solve like a paper, like a test paper. Doesn't matter how many questions are incorrect. It doesn't bother me at all, as long as you are putting the honest effort without using the internet, without using the doubtnut or any other XYZ resource. You have to put your brain, your own concept. You can see, you can check the formulas, you can revise the notes a number of times while solving those exercises, but it is a recommendation come request. Don't find the solution on the internet. Those are only a temporary solution that most of the time you don't understand. Right. अभी इसमें charge density is variable. So जैसे जैसे हम सेंटर से बाहर की तरफ जा रहे हैं, इसकी डेंसिटी कम होती जा रही है और हमें इस पॉइंट पे कैलकुलेट करना है इलेक्ट्रिक फील्ड. We have to calculate electric field at a point which is at less than capital R. So to apply the electric field here, हमें इसके अंदर का total charge निकालना होगा. और charge calculate करने के लिए we cannot do this time charge density into volume, because density is changing with the radius. At a given radius of R, if we consider a small volume dr, so small thickness dr, then in this volume only, the for same radius of R, इसके अंदर density same होगी at every point. For this small spherical shell, we can calculate charge by using the charge density into volume. Consider a spherical shell of radius R and thickness dr. तो इनमें से कुछ क्वेश्चंस या कुछ चीजें ट्रिकी लग रही हैं, डिफिकल्ट लग रही हैं अभी, तो अच्छी बात है. You have to revise it again. All these questions that we solve in the class, as a thumb rule, you are supposed to solve those questions again on your own without seeing the solution. एक बार मैंने करा दिया है और एक बार आपको इन्हीं क्वेश्चंस को दोबारा अपने आप करना है based on the memory of this class. Don't see the solution, don't try to mug up the solution. और रेडियस पे dr थिकनेस का हमने एक छोटा सा शेल कंसीडर कर लिया. इसके अंदर जो चार्ज होगा, द charge on this shell dq, it will be charge density into volume, and volume is 4 pi r square dr. Rho is density, volume is 4 pi r square dr, क्योंकि एरिया होता है 4 pi r square and dr is that height. Substitute d rho as rho naught 1 minus small r by capital R, and then we have to apply this integration. Rho naught 4 pi r square 1 minus small r by capital R times dr. Integrate this to find the total charge enclosed in the sphere of radius r. So if you integrate this, rho naught constant 4 pi constant, अंदर आ जाएगा r square minus r cube by capital R times dr. Integrate from 0 to small r, 0 to q. Q is equal to rho naught 4 pi r square का इंटीग्रेशन r cube by 3 और r cube का इंटीग्रेशन r4 by 4. Now apply the Gauss theorem. Use the Gauss theorem to find the electric field at those points. E dot dA is equal to total charge enclosed upon epsilon. So E into 4 pi r square is equal to rho naught into 4 pi. R cube common कर लो 1 by 3 minus r upon 4r. divided by epsilon naught. So 4 pi gone, r square से r cube gone. Electric field E becomes rho naught r by epsilon naught 1 upon 3 minus r upon 4 times r. This is the electric field at a distance r inside the sphere. Okay. So जो हमने फर्स्ट क्वेश्चन किया था उसमें डेंसिटी वाज कांस्टेंट. जब हमने अंदर चार्ज कैलकुलेट किया था, there we didn't need to do the integration in the very first question of today, this question. इसमें जो अंदर कैलकुलेट करना था तो हमने सीधे सीधे कैलकुलेट किया डेंसिटी इनटू वॉल्यूम because here density was constant. Now in this question density is not constant. Density is function of small r. It is changing with small r. So because of that there will be a different charge in the different radius. We need to first consider a small spherical shell and then we will integrate this for the entire shell. Very nice. Okay, so these questions are good. I mean, good as such. These questions are quite good for the concept development of computer level as well. So I'll suggest that all these questions you should try again once on your own if not understood well in the class. Okay, so it's going to take more time than expected, and I'm okay with it because these are the questions which have been asked in the previous set exam, and these are a very relevant set of questions. वैसे हमने क्लास में इनके सबके कॉन्सेप्ट कर रखे हैं. If you try, you will be able to solve at least half of it. Question number 13 में भी similar concept है, so that I am leaving for the homework. In this case, it is the same as the previous question. Density is a function of r. So density is changing. Accordingly, we'll integrate for charge. Question number 13 is in homework. 14 onwards, we will do in next class. Okay. Yes. So I assume कि अभी exam किसी के नहीं आने वाले हैं. School का कोई भी test हो अगर. This exercise is not only for the school. This exercise is for understanding and development of this entire chapter from the all point of view, school as well as and I have already instructed you to solve questions from NCRT, and now since you are grown up, so no one can check and verify what you are doing, but cross check will be done randomly from some of you. So NCRT exercise is the homework exercise only. Reading the NCRT is mandatory. You can read if you want to, otherwise it's
Chapter
okay.
1.
Yes, I'm talking about chapter 1 because chapter 1 is completed now. SL Aurora, the in-text questions, it is just for you to make comfortable of each topic. If you are not comfortable by solving 2-3 example, to gain the momentum, to gain the more confidence, you can solve either all or at least 50% questions from the exercises in test exercise from the SL Aurora. Then I am solving DPP for you in the class that you have to resolve on your own. And then I am giving you a homework exercise from the 100 Plus Academy booklet, exercise from 100 Plus booklet, which has some good number of questions, but it is not the difficult one. It is the mixed set of question bank. So you have to solve it along with the chapter from the next chapter onwards, like potential and capacitance. We have started, so you can start the potential question also. After this only, I can say that you are now ready for test. Some topic-wise test as I uploaded in your user 100 Plus Academy app. Very few people have given those tests. So again, I'm re-uploading those tests to solve those objective questions on your app, the 100 Plus Academy test app. And it is the 30-minute questions, 30-minute, 20-minute test. So it is just for the, again, getting into this kind of net practice. You are just checking your concept clarity with those tests. And then there will be JEE level test, which have been uploaded. I don't know you got the message or not. JEE test will be there, and then there is a subjective test. So don't leave anything for the last. Things have become again online, so make first yourself comfortable. First make yourself comfortable that yes, you can learn at this mode also. And in fact, trust me, last year those who utilize online mode well, they have done wonders, more than what was expected from them. They have achieved more than that because of this reason that there is a lot of time and energy saved. So as long as it is there, 1 month, 2 month, 3 month, use it to your fullest. Okay. And yes, be safe and stay at home. I'll share this PDF. Don't worry, chemistry class is starting. I'll share this PDF also, and try to solve the remaining questions on your own. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.